Okay, so here's our lesson 15.2. We're talking about the angles of inscribed quadrilaterals. So let's remember what all of that means. Inscribed means the angle I'm talking about has a vertex on the circle. Also, remember that inscribed angles are going to be half of the arcs they intercept. Quadrilateral, remember we have quadrilateral island. We have our parallelogram family. So quadrilaterals are anything that have four sides. So remember our parallelogram family. I'm just going to draw that out for us, right? We got our parallelogram family with rectangle mom and rhombus dad and square is the baby. And then also on the island, right, we have our weird cousin Joe, who's the trapezoid. And I guess this can be our cool cousin because at least this is isosceles. And then we have definitely a weird cousin, right? Trapezoid that doesn't have equal legs. So we're going to be coming back to those here in just a minute. But let's focus just on how these are related to circles. All right, so what I'm actually going to do to show you some of the relationships is walk you through a proof that they've got for us here and see if you can make sense of what they're trying to show us and maybe why that is. So we're going to use this inscribed quadrilateral here in circle O, and the quadrilateral is ABCD. So it says step 1, the union of arc BCD and DAB is a circle. Okay, I agree with that. Therefore, if I add those two together, I should get the total circle measure, which is going to be 360 degrees. Angle A is an inscribed angle, and its intercepted arc, that means the arc that it's opening up to, is going to be, let's see if I draw that, that means that's going to give me this arc DCB. All right, some other angle, so they're asking me to fill this in, some other angle opens up to arc DAB. So the arc DAB, well, that comes from this angle C right here, angle C. So by the inscribed angle theorem, the measure of angle A equals 1/2 of the measure of arc DCB, and the measure of angle C equals 1/2 of the measure of DAB. Okay, you all know all of those things to be true. All right, so the next step, it says the measure of angle A plus the measure of angle C equals, they're wanting me to use substitution. So we're going to substitute those values that we just wrote down. 1/2 of DCB plus 1/2, here I'll keep the colors the same, 1/2 of DAB. All right, now the distributive property, this is really, if you want to make a note of this, you're really thinking about factoring. So I know it's been a long time since you've done that, but we're thinking if there was something that had been distributed, looking at this step, how could I write this so that something would have been distributed in the first place? And to me, I see both of these have a 1/2 in common, so I'm going to pull that to the front and rewrite this as 1/2 DCB plus DAB. And I am not using very good notation here because I'm limited on space, but all of those should have arcs over them. All right, the substitution property of equality means I can substitute some equal value. And at the very beginning, we said this statement that if we add those two arcs together, we're going to get 360. All right, so that means I could write this as 1/2 times 360. And to simplify, which you all know I should really write substitution there, well, what is 1/2 of 360? And the answer, hopefully, for you is 180. So think about that. What this is saying is that if you add the measure of angle A plus the measure of angle C, you're going to get 180. Okay, so the way that we're going to state this theorem is to say that opposite angles in an inscribed quadrilateral are supplementary. So when I say opposite angles, I'm talking about like A and C. Those are supplementary. I could do this same proof and show you that D and B are also supplementary because they are opposite angles. So along with this work, I would have that theorem written down for yourself in your notes. All right, so we're going to look at these two kind of thinking questions, and then we're going to look at one problem that we are just actually going to work out, and then you should be good. So this first question, question 3 here, says, what must be true about a parallelogram that is inscribed in a circle? So let's first of all think about our parallelograms. We've got a few different options. So we have our just basic parallelogram. Remember, that means opposite sides are congruent. and parallel, and it also means opposite angles are going to be congruent to one another. In the family, we have a rectangle. That's all right angles. And then in a square, well, obviously you know a square. And then a rhombus has congruent sides and opposite angles congruent. It is really hard for me to mark this. Remember, in a rhombus, opposite angles are congruent, but not all angles are congruent. So what must be true about one that is inscribed in a circle? Well, in a circle, we know if it's inscribed that opposite angles need to be supplementary. So it's not that they need to be congruent, but they do need to be supplementary. They have to add to 180. So for instance, this parallelogram, that cannot be inscribed because those, even if you're just based it on this picture, both of those angles are obtuse. So they're obviously not supplementary. You can't add two obtuse angles and get 180 degrees. So this cannot happen. Just a basic parallelogram. A rectangle would work because 90 plus 90. So it could be a rectangle. It could also be a square. And for the same reason that it can't work for a basic parallelogram, it can't work for that. So what must be true? It must be that the inscribed quadrilateral parallelogram is either a rectangle or a square. Those are the only options because those are the only things that have opposite angles that are supplementary because 90 plus 90 is 180. All right, question 4 says, some quadrilateral, PQRS, is inscribed in a circle, and the measure of angle P is 57. Is it possible to find the measure of some or all of the other angles? Well, they name quadrilaterals in order, so PQRS is going to mean PQRS, and I'm just making up where these are, PQRS. That is named in order. So if we have PQRS, then I know opposite of P is R. Opposite of P is R. So if I could figure out the measure of angle R because those are supplementary. So the measure of angle R here would be 123. Okay. I do not know, though, anything about S and Q. So R would be the only thing that I could find out there. And the reason is because it's opposite of P, so they're supplementary. All right, and our last problem in this section, they're asking me to find the measure of each angle inscribed. Notice that they give me 3 of the angles. Okay, so it's always going to look like they're giving you more information that you need because we know it's just these opposite angles, well, I don't know why it did that are going to be supplementary. So U and W are supplementary, which means I can set up an equation that the two of these equal 180 degrees when it's added together. All right, and then you can pause the video here for a second. We're just going to work this out to find the the value of Z. So I did that and I got Z to be Z to be 10. And then they wanted me to find all the angles. So to do that, I'm going to need to plug back in. So some of that is really simple, like T, I can do that right now. T is going to be 115 degrees. 10 is a pretty easy number to work with. So W is going to be 87 degrees. And let's see, 120 minus, that's going to be 93 degrees. So I get the first few just by plugging in, but sometimes people are confused, well, how do I find this last one? Because they don't tell me anything about angle V. Well, remember, this is a quadrilateral, and the sum of all the angles in a quadrilateral is always going to be 360 degrees. Remember, that's that n minus 2 times 180 formula, where n is 4 because there's 4 sides. So if I know that that's 360, I could go ahead and add the rest of these together and then just subtract them from 360 to find that remaining angle measure. All right, so those are added together 295, which means this remaining angle is going to be, the measure of angle V is going to equal 65 degrees. All right, so that's how you are going to solve those problems.